we're now going to work problem 6 from section 0.6 on factoring. And what makes this problem different from the last one that we did, problem 4, is that this one has 4 terms in it. And if I look at each term, I do have a common factor of 5 between the first 2 terms, but I don't have a 5 in the third term or in the last term. I can't factor a 5 out. It's not common to all of the terms. Likewise, I have a y in a couple of the terms, but not the others. I have an x in a couple of the terms, or an x squared, but not the others. And so I can't use the technique that I used in the last problem of finding a common factor or common factors to all of the terms and factoring it out. But what I can do is I can manipulate the way that I write this just a little bit and end up having a factored expression. Or I can give you 2 expressions that I multiply together in order to get this. The secret to doing it is what we call grouping. I'm going to group a pair of terms together. And the problem that this gives to students who are new at this is when you first look at it, you may or may not, something may or may not occur to you as to which terms to group. And my answer to that would really be there's always a reason for doing what you do. If you don't see it, it's just because you don't have enough experience, then just try grouping any pair of terms. Try the first 2. And when I say group them, I'm going to put them in parentheses, like so. Now be careful right here, because I have this minus sign in front of this term. Now, I'm going to say this, show you how it works. But if you have a minus sign in front of this term, and you're going to factor the minus sign out, you're going to put an expression here that you're subtracting from these 2 terms. That's going to change the sign of this term and make it positive. It's going to change the sign of this term and make it negative. Stop and think. The reason that works that way, if I have a minus sign in front of an expression in parentheses, I subtract the x squared y, which gives me the negative x squared y here. I subtract the negative 4x squared, which gives me the positive 4x squared there. So when you have a minus sign in front of a term, be careful. If you put that minus sign outside the parentheses, change the sign of each of these terms inside the parentheses, so that what you have here really is the same as what you have here. Now, this is what I meant by grouping. I've grouped the first 2 terms together in a set of parentheses. I've grouped the the last 2 terms together in a set of parentheses. I'm subtracting this expression minus this expression. Now, I'm going to use the technique that I showed you on the last problem, and I'm going to take the first 2 terms here, and I'm going to say to myself, is there a common factor to these 2 terms? And the answer is obvious, yes, there is, a factor of 5. I can factor a 5 out of each of these terms. I'm going to put the 5 outside the parentheses just for these first 2 terms. If I take 5y divided by 5, I have y. If I take negative 20 divided by 5, I have minus 4. And so these 2 factors, 5 times the expression y minus 4, gives me those 2 right there. Now, I'm going to do the same thing over here. I'm going to look at the x squared y minus 4x squared. I can factor an x squared out of each of those terms. I can divide each of these by x squared. What you're going to divide them by, you write outside the parentheses. If I take the term, now notice the negative sign that's here, I just brought it along. If I take the term x squared y divided by x squared, that leaves me with the y. Again, what I'm really doing is I'm saying x squared y, this term, divided by what I'm factoring out, the x squared. And of course, these would cancel, and that leaves me with the y, which is where that y comes from. If I take minus 4x squared and divided by x squared, to factor x squared out, that leaves me with a minus 4. Again, if I had minus 4x squared, and I divide that by x squared, what I'm factoring out, those cancel, and leave me with minus 4. Now, this has done me a great deal of good. You may or may not see it just yet, but here's what I'm going to do. If I will look at this, what I have written here as one expression minus another expression. One expression minus another expression. Between these 2 expressions, do I have a factor that's common to both of them that I could factor out? And the answer is yes. The expression in parentheses y minus 4, that is a factor of this first expression. It is a factor of this second expression, and I can factor the common factor out. I will do that by writing it out in front of y minus 4. I'm going to put parentheses. If I take 5 times y minus 4, and if I divide that by y minus 4, where the y minus 4 is canceled, and leave me with 5. Now, I have a minus sign right here. If I take the expression x squared times y minus 4, and I factor out the y minus 4 factor, I divide it by that, the y minus 4s would cancel, and leave me leave you with an x squared. Now look what I've got. I have one binomial times another binomial. If I were to multiply these two binomials together, multiply each term here by each term here, use the FOIL method even though your inner and outer terms won't combine. If I multiply this binomial times this one, I would indeed end up with what I started with. And so the question is, and I'm going to erase this now, what two expressions did I multiply together in order to get what I started with, in order to get this? I multiplied the binomial y minus 4 times the binomial 5 minus x squared. And again, you don't see how this is going to be of any benefit or use now, but you will when we get to the next section, section 0.7, on simplifying expressions. So this is how you factor an expression like this. What stands out to you that you're going to probably try to use the grouping technique is the fact that you had 4 terms. And often when you see 4 terms, you're going to want to factor that by grouping. Now, I'm going to show you something. Here's our answer. It often does not matter how you group the terms. I could have done it differently. For example, watch this. I'm going to take the first term and the third term, and I'm going to put those together. 5y minus x squared y. Now that's this term and this term. That leaves me with this term and this one. Minus 20 plus 4x squared. I'm going to factor a 4. I'm going to put these in parentheses. 5y minus x squared y. Now if you put it in parentheses, remember to change the sign of each term. That'd be 20 minus 4x squared. I'm going to look at these two terms. I'm going to erase my answer. You can look at it again in a moment, or you can always replay the video and go back to that point. But right here, these two terms. Now, what I'm trying to get across is I'm grouping them differently, but I'll still get the same answer. In these first two terms, do I have a common factor I can factor out? The answer is yes, a y. I'll factor the y out, which leaves me with 5 minus x squared. You know that this is correct because if you multiply 5 times each of these terms, you'll get what you started with. In this last expression, I can factor a 4 out of each of these terms. Put my 4 out in front of the parentheses. 20 divided by 4 is 5. 4x squared divided by 4 would be minus x squared. Now notice, again, I've got one expression minus another expression. Do I have a common factor in each of those expressions that I can factor out? Yes, I do. I have a 5 minus x squared. So I'm going to factor that out. 5 minus x squared. What do I have left? If I take this first expression and divide it by the factor of 5 minus x squared, they'll cancel and leave you with the y. This expression, I factor out the 5 minus x squared divided by that, minus 4. And if you'll notice, that's exactly the same answer that we had before. Now, it does not matter if you write it this binomial times y minus 4 or y minus 4 times 5 minus x squared. When you multiply things, it does not matter what order you multiply them. And so, the comfort that that gives to you, is there more than one right way to do a problem like this? Yes. If you group two of your factors together and you can't see how to get from there to the next step, try grouping them differently, and that will likely solve the problem for you. And that was problem 6.